Hello and welcome to T2 Day 15 of Honors Precalculus. This is part 2. So we're going to continue talking about the law of cosines and sines, and the first thing I'm going to tell you is when using the law of cosines, go and find the larger angle first, and when you're using the law of sines, go and find the smaller angle first. As for y, that will become apparent as we use them more and more. You'll see what happens. So we're going to solve this triangle right here. We only have sides. We have side lowercase b, we have lowercase c, and lowercase a. We don't have any angles, so we're going to have to use the law of cosines once to get one of the angles. So which one looks like it's the biggest? Well, b looks like it's the biggest here. So what we're going to then do is say that lowercase b squared equals a squared plus c squared minus 2ac cosine of b. And we have values for all of the lowercase things. So we know that it's going to be 7.43 squared equals 3 squared plus 5 squared minus 2 times 3 times 5 cosine b. And that looks big, but it really isn't. We just need to isolate this cosine b. So we can do out a little bit of algebra and get that next line right there. And let's just move things over. 7.43 squared minus 9 minus 25 equals negative 30 cosine b. So then you can write it as that fraction. So that means that b is equal to cosine inverse of this whole thing. And it looks really big, but it's not, because when it's that big, you just plug it into your calculator. So what you get in this case is b is equal to 134.978 degrees. And in this case, we are staying in degrees. So we now know that b is 134.978 degrees. Now that we have one of the angles, we can use the law of sines. So we just used the law of cosines here. So now we're going to use the law of sines. So we have the opposite sides here. So what we can now write is sine of a over a, so that's 3, is going to be equal to the sine of 134.978, the angle we just got, over the side length opposite angle b, which is 7.43. So what that tells us, therefore, you multiply by 3, you get sine of a is equal to 3 times this. So it's the same thing again, 978 divided by 7.43. So a is equal to sine inverse of this whole thing right here. And when you do that out on your calculator, you end up with 16.596. We also now know that angle A degrees, plus the angle B plus C degrees is going to be equal to 180 because it's a triangle. So we know that C is therefore going to be 180 minus 16.596 minus 134.978. So angle C in this case is going to be 28.426 degrees. We have now solved this because we now have the missing angles. We had the 3 sides to begin with, and we had the missing angles. Now, you could repeatedly use the law of cosines, but you don't need to. That's too much work. You use the law of cosines once, and then you use the law of sines to find the other 2 angles. Now, it's important to realize there's something called the ambiguous case, and that's when you're given the angle, a side, and a side. And yes, there's lots of jokes in geometry when you use this. But the reason this happens is if you're just given an angle, so let's say you had some angle here. So we're going to start, let's just make something up like 40 degrees right here. And I said you went out, I don't know, let's say we went out another side length of 12. So I gave you a 40 degrees and then 12, and then let's say, I don't know, 8. I'm just making something up here. So let's go 8. You could get a triangle that looks like this, but that same information could make a triangle that looks like this. So there's 2 possible triangles. There's this first one here, but then there's another one that goes all the way around. There's 2 different triangles that you can come out. So you could have, if I tell you 40 degrees, 12, and 8, you could end up with 2 different triangles. You could end up with triangle A, B, C, or you can end up with triangle A, B, D. So you have to check to see if there's 0, 1, or 2 solutions whenever you're doing this. So let's see what happens. If I'm given 40 degrees, B is 8, and A is 6, the first thing you need to do is draw what's going on. We call that A right there, so 40 degrees. And so this angle right here will be the 40 degrees. So there's 40 degrees right there. And I'll make that a little thinner so it'll fit a little better there. And we're going to have this side length, We'll call this point C, and it's going to come back down here, and this is going to be called angle B. So we have three angles here, angle A, angle C, and angle B. And it tells us that B is 8, so this is 8, and A is 6 right there. The thing is that you could also draw this like this as well. So there's two cases. There's this case, and then there's the one that goes to this point D right here. There's two different cases because the 6 could be both cases, both directions. It could be either one. So you have two different triangles. This represents two different triangles. So let's first solve ACB, the triangle that goes from this vertice to this vertice to this vertice. So the first thing we know is that we have an angle here, angle A, and its opposite side. So we can write sine of 40 degrees over 6. And let's go to this angle right here. Let's try this one right here, because we're using law of sines. Let's try that one. Is going to be sine of B over 8. And what this allows us to do is solve for angle B. So when you multiply by 8, you end up with sine of B is equal to 8 sine of 40 over 6. So sine inverse of 8 sine 40 over 6 is going to be B. So when you do that, you end up with angle B is equal to 58.987 degrees. So then how do you go about finding the others? So you know that this right here, we know this one right there. So if we want the upper angle right here, if we want the top angle, in this case the big C, so angle C, again, is going to be, when you add angle A and angle B to it, you end up with 180. So what you can do is you can say that angle C is going to be equal to 180 minus 40, because that's the original one that they gave you. Subtract from that 58.987. So angle C is going to be 81.013 degrees. So now we have the internal angles. The last thing we need to do, though, is find the base here. We need to find the distance from A to B, and I'll call those points first, the vertices right there, the vertex A to vertex B. And we're going to do that with the law of sines. So let's call this whole thing right here, we're going to call this one right there C1, lowercase c1, because there's going to be two side C's. So what that tells us is that sine of 81.013 over C1, so the angle over its opposite side, is going to be equal to sine of 40 over the opposite side there, which is just 6. So then you can write this out, and you end up with C1 is equal to that, and you need a calculator, so that side length, lowercase c1, would be 9.220. So we have the three angles here, C, and we were given A, and then we have the missing side. Now the other triangle, though, is there's still another triangle there. There's the triangle ACD. So we need to solve that triangle as well. So we end up with that triangle, I'll roughly sketch it right there, is this one right here. And we know that this right here is 40 degrees. We know that this is 8, and we know that this is 6. So we'd love to know more angles here. So this goes out, and the other triangle was right there, and we knew that that one was 58.987 degrees right there. And I'll write it off to the side so it's easier to see. So that angle right there is 58.987 degrees. Well, because this is 6 and that's 6, this also has to be, that angle right there has to be 58.987 degrees. And this whole angle from here to here is 180 degrees. So let's call this angle right here, we'll call this angle right here, the purple one. We'll call that, let's say that's angle alpha. Angle alpha will be 180 minus 58.987. So that base angle right there is going to be 121. Alpha is going to be 121.013 degrees. So now that we have that base angle, we can find, let's call this one right here, this angle beta. So we know that beta is just going to be 180 minus 40 minus 121.013. So that top angle, the top angle right there is going to be 18.987 degrees. So now we have the internal angles, and we have 2 of the sides. Now we need 3 of the sides. So we have this angle now, which is opposite the side length we want. We want this green side length right here. So what does that tell us? We'll call that C2. We'll call that C2 right there. So what that tells us is that sine of 18.987 over C2, because of the law of sines, is going to be equal to sine of 40 over 6, the same one. So when you do this out, you end up with C2 is equal to 6 sine of 18.987 all over sine of 40, and you have to use a calculator, and you will get 3.037. So there's 2 possible triangles, so there's 2 things to solve. There's a lot going on here. I'm going to do 2 over to the side so there's more space. So what's going on here is we have 30 degrees, 4 and 6 as our 2 other sides. So when we draw this, we have to be very careful about it. The initial angle right here is going to be 30 degrees. So we'll call that C right there. And then the opposite side is going to be 4. And then B is going to be 6. So if that's 6, this right here is going to be B. So this is lowercase b. This is lowercase c, and we'll call this A right here. So this will be lowercase a. The other side could be here. This side could swing over there and be the same information but a different triangle. Same information but a different triangle. So let's figure out the first big one here. We'll call this B1 here. B1. And remember, A is the length of this side right here, the length. Okay, so what does that mean? It means that sine of B1, whatever that angle measure is, over 6 is going to be equal to the sine of 30 degrees over 4. So when you do this out, it means that B1 is going to be the sine inverse of 6 sine 30 over 4. So B1 is going to be equal to 48.590 degrees. So now we have this. This is that number right there. So if we want to get this angle A right there, how do we get angle A? Well, A is just going to be 180 minus 30 minus 48.590. That's angle A right here, angle A. So that is going to end up being, 101.41 degrees. But now, so now we have this angle right there. We have this is 101.41 degrees. We now need to find the side length of A. So we're going to use the law of sines to do that. So that means we'll call this A1 right there. So that means that sine of 101.41 over A1 is going to be equal to something we've used before, sine of 30 degrees over 4, the other ratio. So that means that A1, the first base there, is going to be equal to 4 times sine of 101.41 all over sine of 30. And you need a calculator for that. So that first missing base is 7.842. So then the second triangle is the one with the dotted side there. The dotted side. So you had the second triangle. So that second triangle, I'll draw it a little bigger here, is going to be this one right here. I'll try to draw that a little bit more cleanly, like this right there. And the full one we just did was this one right there. So this was 4, and this was 6, and this was 30 degrees. And so how are we going to do this? Well, we'll call this right here, we'll call this point right here B2. So what is that angle going to be? How do we figure out what this new angle, let's make it green here. What is this angle going to be? Well, you know that sine of 30 degrees over 4 is going to be equal to sine of B2 over 6. So you can do this out. You end up with sine of, you end up with sine of B2 is equal to 6 sine 30 degrees over 4. So when you do this out, you use sine inverse, and you end up with B2 is equal to 131.41. Now another way to do that is from the first one. You might remember if we knew this angle, which we got, which was 101, not 101, it was 48.59, 48.59. That also meant that this angle right here had to be 49.51. So you can do 180 minus that to get this, which would also come out to be that right there. So then if we want to do that, we need to get this angle up here, this angle right there. We'll call that this angle right there. Call it alpha. That's fine. So you know that alpha is going to be 180 minus 30 minus 131.41. So that alpha is going to be equal to 18.59 degrees. The last thing we need is this A2 base, this length right here. Now that we have that alpha, what we can write is sine of 18.59 over A2 is going to be, pick which one you want. I'm going to do a sine of 30 degrees over 4. So now when you solve for this, you cross multiply and use your calculator, you get A2 is equal to 2.550. Takes practice, draw pictures, draw them carefully, and really be comfortable with the sine ratios and the formula for the law of cosines. The answer's over there.